Good morning everyone. So we are going to discuss about differential units and steering system in tractor. First let's see about the differential unit. It is a special arrangement of gears to permit one of the rear wheel of the tractor to rotate slower or faster than the other. While turning the tractor on a curved path, the inner wheel has to travel lesser distance and the outer than the outer wheel. The inner wheel requires less power than the outer wheel. This condition is fulfilled by differential unit, which permits one of the rear wheel of the tractor to move faster than the other at the turning point. The output shaft comes from the gearbox, is provided with the bevel pinion at the end of the shaft. The bevel pinion is a mesh with large bevel wheel known as crown wheel. The main function of crown wheel assembly are to transmit power through right angle drive to suit the tractor wheels to reduce the speed of rotation. The differential unit consists of differential casing, differential pin, crown wheel, half shaft, bevel gears. The differential casing is rigidly attached with the crown wheel and moves with one unit. Two pinions are provided inside the differential casing such they are carried round by the crown wheel, but they are free to rotate also on their own shaft or stud. There are two or more bevel gears in the mesh with differential pinion. One bevel pinion is at the end of each half shaft, which goes to the tractor rear wheel. Thus, instead of crown wheel being keyed directly to the solid shaft between the tractor wheels, the drive is taken back from the indirect route through differential casing, differential pinion, and half shafts the tractor. When the tractor is moved in a straight line, the differential opinion does not rotate on the step shaft but are solid with the differential casing. They drive the two bevel gears at the same speed and in the same direction as the casing and the crown wheel. Each differential pinion are moved in two planes simultaneously. When it is carried round by the casing, it drives the half shaft in the same direction, but when it is rotated on its own shaft, it drives them in opposite direction. That is, rotation of differential pinion adds motion to one shaft and subtracts motion from the other shafts. Differential lock. It is a device to join both half axle of the tractor so that even if one wheel is under less resistance, the tractor come out of the mud, etc. as both wheel moves with the same speed and apply equal traction. Final drive. It is a gear reduction unit in the power trains between the differential and the drive wheel. Final drive transmits the power finally to the rear axle and the wheels. The tractor rear wheels are not directly attached to the half shaft, but the drive is taken through a pair of spur gears. Each half shaft terminates in a small gear which meshes with the large gear called bull gear. The bull gear is mounted on the shaft carrying the tractor gear wheel. The device for final speed reduction suitable for tractor rear wheel is known as final drive mechanism. Next is steering system. The steering system is required to control the direction of motion of the wheel. This is done through a series of links used to convert the rotation of the stationary wheel into change of angle of axis of steering wheel. Another function of the steering wheel is to provide directional stability. The motion of the wheel being steered need to become straight ahead when the force on the steering wheel is removed. The design of the steering system should be such that it should cause minimum wear of the tires of the wheel. The steering system can be classified into from wheel steering, rear wheel steering, or all wheel steering. The system governing the angular moment of front wheel of the tractor is called steering system. The system steering wheel minimizes the effort of the operator in turning the front wheel with the application of leverages. The different components of the system are steering wheel, steering shaft, steering gear, pitman arm, drag link, steering arm, tie rod, and kingpin. When the operator turns the steering wheel, the motion is transmitted through the steering shaft to tire angular motion of the pitman arm through a set of gears. The angular moment of the pitman arm is further transmitted to the steering wheel through a drag link and tie knots. Steering arms are keyed to the respective kingpins, which are integral part of the subaxle on which wheels are mounted. The moment of the steering arm affects the angular moment of the front wheel. In other design, instead of one pitman arm and dragging link, two pitman arm and dragging links are used, and the use of tie rod is avoided to connect both steering arms. Tractor tire and front axle. The tire are available in many sizes with a plate rating as 4, 6 or 8. The plate rating of tires indicates the comparative strength of tire. The higher the rating, the stronger are the tires. The tire size 12 to 38 means that the sectional diameter of the tire is 12 inch and is mounted on a rim of 18-inch diameter. The inflation pressure in the rear wheel of the tractor varies from 0.8 to 1.5 kg per centimeter square. The inflation pressure on the front wheel varies from 1.5 to 2.5 kg per centimeter square. Useful life of pneumatic tire under normal operating condition may be about 6,000 working hours for drawbar work. Front axle and steering mechanism. Front axle. It is generally death axle. The front wheel hubs rotate on anti-friction bearing of tapered roller type on the steering spindle, which are an integral part of steering knuckles. To permit the wheel to be turned by steering gear, the steering spindle and steering knuckle assemblies are hinged at the end of the axle. The pin that forms the pivot of this hinge is known as kingpin or steering knuckle pin. Front wheel alignment. The front wheel must be in correct alignment in order to ensure easy steering, to give directional stability of the vehicle and to minimize tire wear. Front wheel alignment is obtained through accurately setting the following factors: caster, camber, kingpin inclination, toe in and toe out. First we can see about caster. Caster angle is the tilt of the kingpin or ball joint center line from the vertical towards either the front or rear of the vehicle. The caster angle produces a tailing effect and hence gives the directional stability. Incorrect caster can produce difficulties like hard steering, pulling to one side when brakes are applied. The caster angle ranges from 2 to 8 degree negative. Camber. Camber angle is the inclination between the center line of the tire and the vertical line. The outward inclination is called positive camber and the inward inclination is negative camber. The purpose of the camber is to prevent the top of the wheel from tilting inward much due to excessive load or play in the kingpin and wheel bearing. Unequal camber in the wheel causes the wheels to roll in the direction of wheel having the greater camber, which upset directional stability and tend to stuff the thread on the opposite tire. Excessive camber prevents the tire from having correct contact with the road, which causes it to wear only on the side directly beneath the load. Camber angle is less than 1 degree. Kingpin inclination. It is the inward tilt of the kingpin or ball joint center line from the vertical. Kingpin inclination in combination with camber provide directional stability, whereas the kingpin inclination and camber combine to give center point steering of the tire on the road and to bring upward thrust on the step axle more nearly through the center of the kingpin. The combined camber angle and kingpin inclination is called the included angle. Kingpin inclination range from 4 to 8 degree. Next is toe in and toe out. Toe in. Front wheel are usually drawn in slightly in front so that the distance between the back ends is slightly more than the distance between the front ends. The difference between this distance is called toe in. Wheels are towed in to offset the tendency from them to roll outward due to camber and to play in the steering linkage. Toe in is usually 2 to 4 mm. Toe out. When a vehicle takes a turn, the inside wheel moves faster than the outside wheel because the former has to negotiate or with shorter radius than the latter. This action causes the wheels to out on turns because of difference in their turning angle. Steering system. The function of the steering system is to convert the rotatory motion of the steering wheel in driver's hand into angular turn of the front wheel on road. Further, the steering system should provide mechanical advantage over front wheel steering knuckles, offering driver easy turn of front wheel with minimum efforts in any desired direction. There are two types of steering, mechanical steering and hydraulic steering. Mechanical steering. When driver turns the steering wheel, motion is transmitted down through the steering tube to the steering gear. The steering tube revolves inside the steering column. The steering gear changes the direction of motion and increases the turning force applied by driver of the steering wheel in accordance with gear ratio. The gear rotates the steering arm, which transfers the motion to the steering knuckles through the steering gear, connecting rod, tie rod and knuckle arm. This type of linkage is called relay steering linkage. The kingpin torque required to turn the wheel under a vertical load can be calculated by the following equation. T is equal to W into F into IO by A plus E square the whole power 1 by 2, where F is effective frictional coefficient, IO is polar moment of inertia of tire print, E is kingpin offset, A is tire print area. This equation assumes a uniform tire print pressure. If the exact shape of the tire print is known, an approximation can be made by assuming it to be a circular with diameter equal to the nominal tire width B. Then it is given by the following equation. The change in steering torque as a function of kingpin offset is shown by the curve. The curve shows that an optimum kingpin offset E exists for a minimum value of torque T. Also, the optimum offset varies with the differential surface condition. A small kingpin offset or even center point steering in which the offset E approaches 0 is better suited for heavily loaded tires in loose soil where rolling resistance is high. If the steering wheel is also powered or is equipped with brakes, a small or zero offset is also advisable to reduce feedback of forces in the steering system. Importance of wheel alignment. Improves handling. This helps in controlling the vehicle. Improper handling can be due to vehicle pulling on one side, vibration of the steering wheel. Improves tire life and performance. Proper rolling tire contact on road and prevention of slipping of the tire due to improper alignment result in better tire life. Help in identifying problems. Improper alignment could be a symptom of something wrong in the vehicle. A check on this can lead to correction in the fault in the vehicle. Next, ensures safety by keeping the system in order to remove the defective parts, enhance the vehicle system, especially the suspension system, leading to better safety. Next, improves fuel efficiency by enhancing the performance of various systems, lead to better fuel efficiency from the vehicle. Thank you.